Hello, everyone, and welcome to the part 5 of this MCP series. In our session today, we will do a deep dive on MCP clients. Prerequisites for the session is knowledge of Model Context Protocol. Hence, if you do not know what MCP is all about, please refer to this overview tutorial in part 1 and the architecture overview in part 2 that I posted some time back. URLs to both these sessions are mentioned right here at the bottom. They will also be mentioned in the description of this video. Now, of course, it would be great if you can watch the earlier 4 parts, but if not, at least watch part 1 and part 2 before continuing further ahead, as most of the basics have been covered in these 2 parts. I will not be going into the basics. I'll basically just build further ahead and continue. So what are MCP clients? MCP clients are instantiated by host applications to communicate with MCP servers. So you can consider MCP clients as a kind of a component that is instantiated by the host application to specifically communicate with MCP servers. The host is the application that user interacts with, while clients are the protocol level components that enable server connections. Pretty straightforward. MCP clients provide several features to servers that allow the server authors to build richer interactions. So richer interactions with the clients, with the host, and ultimately with the user. So this is at a very high level, just to kind of lay a foundation, and then let's continue further ahead. What are some of the client primitives? Primitives are nothing else but basic building blocks. The first one is sampling. Now, I have discussed sampling in details in the previous parts, but sampling, as for me, is a misnomer. It should actually be completion, because what sampling does is essentially it's a request that the server tells the client to complete on its behalf. And this is particularly related for any AI dependent task. So basically, request language model completions. These are requested by the server. So an MCP server requests AI completion for data analysis, perhaps generating some text, or any other server-side AI tasks. So if there are AI dependent tasks that an MCP server needs to perform, then it can reach out to the client, request it to work and complete that particular task on its behalf. And that is essentially what is sampling. The next one that we have is logging. Logging essentially enables the server to send log messages to the client. So clients basically receive these messages from the server, and particularly clients can use these messages, log messages, for debugging, monitoring, and diagnostics. Next one that we have is elicitation. When a server needs some information from the user, it makes a specific request that, hey, I need this information from this user. So when that request is triggered by the server, let's say server is processing something, and in the middle of that, it needs some information from the user, that's when it will send an elicitation request to the client that, hey, can you please request this specific information from the users? So let's say if you are booking a flight, then the server might request traveler details or might need to know some special hotel requests or possibly ask for emergency contact information. So whenever server needs specific information from the users, that's when elicitation comes into the picture. And finally, we have roots. Now, roots was not discussed earlier, as I personally went through the documentation for MCP. Roots kind of surfaced. In the earlier videos, I have discussed these three primitives for client, but roots has not been discussed. So what are roots? Roots is essentially client's way to basically provide a very restricted access to the server for some specified folders. So let's say if the server needs access to some information, some data in form of files. So what the client can do is it can provide access to certain restricted folders so that the servers can work within those boundaries and access whatever relevant information that is needed. So this is how clients basically provide a file system boundary to the servers and essentially provide restricted access to specified folders. So that is what is roots. Now let us look at each of these primitives in further detail. So sampling allows servers to request language model completions through the client. So an MCP server can request a client who has an AI model to basically perform any AI-dependent task on its behalf. So the server can basically tell the client, can you handle this task and complete this task for me on my behalf? And remember, sampling is typically done when these tasks are AI dependent because it's the client that has the AI model. Sampling basically puts the client in complete control of user permissions and security measures. This is extremely important. Every sampling request needs explicit user consent. So clients need to show what the server wants to analyze and why. And of course, the users have the ability to approve, deny, or modify these requests. Clients need to display the exact prompt, model selection, and token limits. Users can review AI responses before they return to the server. Also, all these sampling requests are performed in isolation from the main conversation. So, the servers cannot access any user conversations. So, you have your server, you have your client, your host over here, and you have your user. Now, this request is sent to the client and the host. Of course, the client displays that to the user. So this interaction between the user and the client, this is personal and private. This is the main conversation that is going on. Of course, there's a conversation that is going on between client and server. But when this sampling request comes in, this is sampling. This is a separate request. And servers cannot access any of these user conversations. So whether the user says yes, no, approves, denies, modifies the request, server does not have any access to this user conversation that happens to this user conversation. Server is basically by itself. So any conversation, especially these sampling requests, these are received and executed in isolation. And yes, the user is in complete control. And that's why you are essentially doing this. So although the server is telling the client, hey, you need to complete this on my behalf, it's not that the request runs without the user's knowledge. So human is in the loop. And only if the user explicitly provides consent or provides approval, then the sampling request is approved and performed further ahead. Now let's take an example and dive deeper into this. So again, we are taking the same scenario that we took for the server. Let's say business travel planning. When a user says, book me the best flight to Barcelona next month, essentially what happens is a server tool is called. So let's say Find Flights is the name of the server tool. And the server tool, of course, eventually will need some AI assistance to evaluate complex trade-offs as per user preferences. So what happens behind the scenes over here? So user gave this prompt. A server tool was called Find Flights. Now this particular server tool queries airline APIs. Of course, it's going to gather X number of flight options. So now it has all the flight options. It will then request AI assistance to analyze these options. So analyze these flight options and recommend the best choice as per the user preferences. Let's assume user's preference was morning departure, max 1 layover. So I have a list of flights. This is my list. But of course, not all flights are going to be the best flight for the user, especially as per the preferences. So amongst this entire list, I have to basically pick and choose the best one. So essentially what happens is the server will go back to the client and say, can you analyze these flights and let me know the best or the recommended choice as per the user preferences? Now, this is a sampling request because now the server is asking the client to perform and complete a task on its behalf, and this task is AI dependent. So what the client is going to do is client is going to ask the user, allow sampling requests. Upon user's approval, AI evaluates trades off. Like, there could be cheaper red-eye flights versus convenient morning departures. Then this analysis is shared with the server tool after, of course, user review. And finally, the tool uses this analysis to present the top 3 recommendations. So now you see the communication between the user, the client, and the server. All 3 are communicating with each other. So essentially what is happening over here is that the AI model, essentially the client and the host along with the user, are basically working on this particular AI model where the AI model is doing some analysis to find the best flight option for the user. Of course, what the server did was gave it all the information. And now it is telling that, hey, can you do this analysis on my behalf? And basically let me know. And then I will use your analysis to find or basically shortlist the top 3 recommendations. Of course, any sampling requests need user approval. Now let's go to the next one, logging. Logging allows servers to send log messages to clients for debugging, monitoring, and auditing. So of course, we all need, debugging, monitoring, and auditing. Something goes wrong. That's how error handling happens. So it is triggered by the server during any kind of operation or error handling. Logging helps the client to receive real-time feedback on server activities. It supports diagnostics and capturing important events or errors. And most importantly, it helps enable performance monitoring and usage tracking. And the best part about logging is that it basically provides transparency between server and client. And this transparency helps to build reliability and trust and leads to faster issue resolution and debugging. So whenever there is an error and the server wants that error to be shared with the client, essentially it sends a log message. And the client will know now exactly what has gone wrong with the server. Again, let's take an example again for business travel planning. So when flight booking fails, the server logs the error and sends it to the client's dashboard for immediate ascension, enabling quick troubleshooting and customer support. So this is your server, this is your client. It sends the log message, and then client, of course, will have a dashboard in terms of an application where this message can be displayed, and then accordingly some quick troubleshooting can be done, or the required customer support action, whatever that is necessary, can be taken. So this is how logging works. It is of course triggered by the server. Next one we have is routes. So routes essentially help clients to define file system boundaries for the server so that the server can only access relevant travel data folders. Or it could be travel data folders or any data folders. Of course, routes are triggered by the client to specify safe directories, and it provides server access to the folders. It could contain user itineraries, travel documents, preferences, or any other information in file format. And why is this thing done? This is done to prevent servers from accessing unrelated files on client's device and maintaining client privacy and security. This is, of course, assuming that this interaction is possible, and of course, there is some form of file communication or file sharing that is needed. So it's not that all primitives will be applicable at all times. Depending on your use case and what you're trying to achieve, certain primitives will be very helpful. So if your use case has some file access or requires the server to access some data in form of files, then you can go for routes. And you can basically help server efficiently locate and use only the necessary data from a specific file system folder. So let's say for business travel planning, the client exposes a directory called as travel docs, and this allows the server to read itineraries as PDFs, update any booking records, and access any personal file or personal file information in form of files that is needed. Any access outside of this particular folder is prohibited. So server has been restricted to only access this particular folder and whatever information is present in that particular folder. If it's not present in that folder in form of a file, then server cannot access that information. So this is restrictive access to file by the client by basically giving server access to a specific folder. Elicitation. Elicitation basically enables servers to request specific information from users. So let's say servers are performing some action, some operation. And during these interactions, they basically need some information. So they can request that information, that very specific information from the user, making the whole workflow interactive and dynamic and responsive. Now, servers can request specific data when needed, and user can provide this information through appropriate UI. Servers, after they receive this information, can continue processing. Now, any kind of elicitation, interactions, or requests are supposed to be clear, should have proper context, and should be respectful. So clients essentially display elicitation requests in which a clear context is being presented to the user. And also the user needs to know why the server is asking for this information, which server is asking for that information, and how this information is going to be used. Users can provide this information using an appropriate UI. They can even decline this or even possibly cancel the entire operation. The user should always be able to review the data before it is sent. So basically, whenever your server needs information, from your client, essentially from your user, it sends this elicitation request. And then the client will show a pop-up or this request to the user using UI. And the user can approve or deny. Okay. So taking our business travel planning example, let's say the server elicitates booking confirmation and basically includes all the trip summary. And as the booking progresses further ahead, the server asks for client details, basically some traveler details for booking, maybe some special requests for hotel or emergency contact information. So this is how, while performing or working on a specific task, an MCP server can request for specific details from the user. And of course, these details are got from the user via the client. So I hope that this video was helpful. Please do post your comments. This is it from me today. If you're new to my channel, do like and subscribe. And thank you very much. I will see you shortly in some other video. Till then, take care. Bye-bye.